All right, guys, so next what we're going to be doing is we're going to be graphing these rational functions, and I'm going to tell you right off the bat, it can get a little hard, it can get a little complicated, but if we stick to the game plan, I think we'll be okay, all right? So when you're graphing rational functions, there are really four things that I like to focus on. The first one will be the vertical asymptote, second will be the horizontal asymptote, then we got our x-intercepts and your y-intercepts. Now, don't forget what your asymptotes are, right? They're invisible lines that our graph does not cross, or they do not cross. Now, our x-intercepts. What are our x-intercepts? Well, they're places where our graph crosses the x-axis. And y-intercept, guess what? That's where our graph crosses the y-axis. We know this, right? So what we got to do is we're going to be given a couple of functions, and our goal is to graph these rational functions without using a graphing calculator or anything like that. But we're going to just kind of use these four clues to help us before we start plugging in numbers. All right, so let's go ahead and let's look at the first one. The first function we're looking at is this guy right here. F of x equals 1 divided by x. Now, the first thing we should do is probably look at where the vertical asymptotes are. Now, if you remember from the vertical asymptote video, how we locate it is we set the denominator equal to 0. We can find the vertical asymptote by setting the denominator equal to 0. Our denominator here is just x, so we have the statement x equals 0. This tells us that where x equals 0, we have a vertical asymptote. Simple as that. All right. And I'm just going to be running down all of this list of four things, and then we're going to put the graph together. Okay, secondly, we have to find our horizontal asymptote. If you remember from the horizontal asymptote video, what we have to do is we have to compare the degrees. We have to compare the degree of the numerator to the degree of the denominator. Now, the degree of the numerator here is 0 because in this sentence right here, there are no x's, okay? If there are no x's, that means the degree is equal to 0. But this guy right here, our denominator, he's x to the first power, right? He's x to the first power. So that means his degree will be 1. So this tells us that the degree of the denominator is greater than the degree of the numerator. So going back to our last video, that tells us that the horizontal asymptote is at y equals 0. If the denominator has a greater degree than the numerator, then the horizontal asymptote is at y equals 0. Okay, the next one on the list, we have to find the x-intercepts. How do you find the x-intercepts? Well, you set your numerator equal to 0. Hopefully I wrote that. Yes, I did. So I set my numerator equal to 0. What is my numerator for this function right here? Well, for this function, my numerator is 1. So I get this statement, a weird statement. It says 1 equals 0. Now, you guys have been doing math for a long time. You guys have been living for a long time. The statement 1 equals 0 is not true at all, right? It's a false statement. So anytime you get some sort of weird statement or some false statement at this step, it's just going to tell us that there are no x-intercepts. Okay, so for this guy, 1 over x, there are no x-intercepts for him. All right, so lastly, let's look at the y-intercepts. The y-intercepts can be found by plugging in 0 into our function, meaning I'm going to replace all my x's with 0. So if I go here, if I plug 0 in for my x, f of 0 equals 1 over 0. And we know we can never have a 0 in the denominator. So what we say is, well, that's undefined. And again, something weird happened, right? We got like a false statement. We had an undefined statement. So similarly, this tells us that there are no y-intercepts. Okay, so what we're going to do now is this. We're going to try to graph this guy, but the first thing you want to do is start with kind of what we know, all right? So what do we know so far? Well, let me come up back here. We know that we have a vertical asymptote at x equals 0. Okay, so let's go down to my graph. This is x equals 0. The y-axis is where x equals 0. At x equals 0, we have a vertical asymptote. So we have an invisible border. Okay, maybe that's not the best thing to use. Let's use red. We have an invisible border that our graph will not go by or cross through. Okay, let's look what else we know. Well, we have a horizontal asymptote at y equals 0. So where is y equals 0 on my graph? Well, y equals 0 is on my x-axis. So that means my graph does not cross this guy either. So we know that my graph does not cross this guy, and he does not cross this guy. So he kind of splits up our grid into like 4 sections. Okay, let's see. Also, we know that there are no x-intercepts and no y-intercepts. Well, that makes sense because we're not allowed to touch the x-axis or the y-axis. The next thing you should do at this point is plug in values. I'm going to plug in values into my function, but I'm not just going to pick any value. I want to pick numbers to plug into my function that are close to my vertical asymptote. So remember, my vertical asymptote was at x equals 0. So what I'm going to do is I'm going to pick numbers around x equals 0. So maybe I'll pick x equals 1, x equals minus 1, x equals 2, x equals minus 2. Okay? Always pick numbers that are close to your vertical asymptote. And you had to pick it on both sides. So see how our vertical asymptote here is at x equals 0. I chose numbers such as minus 1, minus 2, which are on the left-hand side of my vertical asymptote. And then I chose numbers like positive 1, positive 2, which are on the right-hand side of my vertical asymptote. Always include the left-hand side numbers and the right-hand numbers. Don't just do one. You got to do both. Okay, so let's see what happens. Got to give me a second right here. My pen is being a little laggy. Okay, so I plugged in minus 4, minus 2, minus 1, 1, 2, and 4 into my function, which was 1 over x. Okay, so if you plug in minus 4 into 1 over x, you get minus 1 over 4, and so on and so forth. So what's going to happen here is I'm going to start plotting these points. So when x, I'll zoom out to make our life a little bit easier. So when x is minus 4, I get minus 1/4. So it looks like this. When x is minus 2, I get minus 1. Maybe I did this the wrong way. I get minus, sorry, I always do this, right? Come on, let's go the right way. Minus 1 over 4. Boop, boop, boop. Okay, good. So now when I have minus 2, I have minus 1/2. So which way should this be going? 1/2 is bigger than 1 over 4. Sorry, this is not going to look that pretty. And when I plug in minus 1, I get minus 1. So it looks like this. Okay, and I'm going to do the same thing on the other side. So at 1, I get 1. At 2, I get 1/2. And at 4, I get 1/4. So it looks like this. So we have everything in place to make this graph work, or to draw our graph completely. The only thing you have to do is connect these dots. Now here's the thing. When I connect these dots, I have to make sure I abide by the rules of the asymptotes, okay? Meaning, if I were to just connect my dots like this in a straight line, I cross the vertical asymptote and I cross the horizontal asymptote. And that's a no-no, right? So we're not going to do that. We have to, come on, we have to construct or we had to connect these dots in a way where we kind of avoid our asymptote. So look how this will come about. I'm going to connect my dots, but once my dots start getting close to an asymptote, I'm going to start veering out of the way. So it's going to start doing this. It's going to start doing everything in its power to get out of the way of the asymptote. And the same thing happens here. As I get closer and closer to my y equals 0 asymptote, this guy almost looks like he's leveling out. He'll bend himself out of the way in order to not get in order to avoid this horizontal asymptote. And the same thing will happen with these three dots, okay? So when they're connected, they're going to try everything in their power to avoid the vertical asymptote, and they'll avoid the horizontal asymptote on the other side. So it's not the best graph, but this is the general picture of our function y equals 1 over x. Okay, I connected my dots in such a way that I had to avoid my horizontal and my vertical asymptote. So if by the end of the question you realize your graph has crossed either of these asymptotes, you've done something wrong. Maybe your points were off, or maybe you just forgot that you couldn't cross the asymptote. All right, so we have three more. This is a big section, so I included a couple of extra questions. Let's look at this guy. Here's the graph. Well, our goal is to graph this function. F of x equals minus 3x minus 5 divided by x plus 2. Again, our first goal here is to find the vertical asymptote. To find the vertical asymptote, I set my denominator equal to 0. So my denominator, I set it equal to 0. So I have x plus 2 equals 0. Solve for x, I get x equals minus 2. This tells me that I have a vertical asymptote at x equals minus 2. Right? So on my graph, here's minus 2. I'll have an invisible line that blocks any points or anything from crossing it. Okay, so horizontal asymptote, remember how we figure that out? We compare the degrees. The degree of the numerator is 1, right? Because there's an invisible 1 right here. And the degree of the denominator is also 1 because there's an invisible 1 right here. So when the degree of the numerator equals the degree of the denominator, how do we figure out what the horizontal asymptote is? Well, we take the ratio of their leading coefficients. So the leading coefficient of the numerator is this guy right here, the term that's connected to my x with the highest power. And the leading coefficient of my denominator is the number, there's an invisible 1 right here, in front of my highest powered x. Okay, so I have minus 3 divided by 1, which is just minus 3. This tells me that I have a horizontal asymptote at y equals minus 3. So if I were to find minus 3, so let's just say minus 3 was right here. There's an invisible line that our graph will not cross. So we got two invisible lines going on like that. Okay, third, find the y-intercepts. How do I find the y-intercepts? Sorry, the x-intercepts. I set the numerator equal to 0. To find the x-intercepts, I set the numerator equal to 0. Doing a little bit of algebra, I figure out that when I figure out that x equals minus 5 over 3, that means when y is 0, x is minus 5 over 3. That means this point exists on my graph somewhere, okay? And same thing for my y-intercept. How do I find my y-intercept? I plug in 0 for all my x's and I get minus 5 over 2. This means that when x is 0, remember I plugged in 0 for x, my y is minus 5 over 2. So that means this point also exists on my graph somewhere. So let's go ahead, let's start graphing this. So we said that there was horizontal asymptote, sorry, vertical asymptote at x equals -2. So we got something looking like this, and then we got something looking like this, -3 for our horizontal asymptote. Okay. We also said that we know that the point -5/3, 0 is on the graph, okay? So let's just say 1, 2, 1, 1. Okay, so -5/3 is a little less than 2, or a little less than -2. So let's just say it's like right here. So that point right there will be -5/3. And I'm just going to erase it so it doesn't look too dirty. And also we know that this point right here, -5/2 is on our graph. -5/2 is a little bit greater than -2. So let's just say it's right here. This point right here is -5/2. So this point, Jesus, I don't know why my pen is being weird. This point is reflected by this guy, and this point is being reflected by this guy, right? I'm just putting them on paper so you guys know where it is. Okay. Boom. Let's get these guys out of here. All right, so again, my vertical asymptote here is at x equals 0. It's at x, sorry, my vertical asymptote here is at x equals -2. It's at x equals -2. Now I want to plug in points into my function that are around -2. So what I'm going to do is I'm going to pick -3, and they already gave us one of them, which is -5/3. See, this point is to the right of it. This point is to the left of it. Always pick numbers that are to the right and to the left of your vertical asymptote. So I'm going to pick two numbers that are to the right, to the left of my vertical asymptote, and I'm going to pick two numbers to the right of my vertical asymptote. So that will be this guy, this point right here, which is -5/3, and I'll pick also the number 5. So here's my vertical asymptote. I picked two numbers to the left of it, and I picked two numbers to the right of it. And I'm evaluating what their y is for these x's. So I'm plugging those x's into our function. And if you remember what our function was, it was this guy up here, right? It was -3x. I can't even remember what it was, honestly. -3x minus 5 divided by x plus 2. So let's see what we got. This guy he's already graphed. Let's deal with this guy. When I plug in 5 into my function, I get -20/7. So that's almost 3, right? So it's almost -3, but not quite. So he's probably right here. When I plug in 5, I get -20/7, which is close to -3. So this guy, we'll plot him right here. If I plug in -3, I should be getting -4. So here's -4. Here's -3. Here's -4. I'm looking at this part right here, actually. When x is -3, y is -4. And that's what I just plotted right here. Now the last one, when x is -5, I get this guy right here. So he's a little bit closer to 3. So he'll look something like this. It's good to know how to figure out what these fractions represent or what their decimal form is. You can always do long division if you need to. Okay, so now our goal is just to connect the dots. So I'm going to connect these two dots first. Remember, if I just connect them in a straight line like this, I cross my vertical asymptote and my horizontal asymptote. which is a no-no. So I want to connect them in a manner such that when I connect them, I'm also avoiding my asymptotes. So they have to curve or bend out of the way. And same thing goes with this guy. I want to connect these 3 dots in a way that they kind of bend and avoid our 2 asymptotes. So rational functions will always look a little funky for the most part. And this one has, it kind of looks similar to this guy, the one that we just did, but translated a little bit. So hopefully that made a little bit more sense to you guys. I wish we can get clean numbers for the y to make your life easier, but we're working with what we got here. All right. You know what? I'll put the next 2 examples on the next video.